In today's video, we'll be solving some exam style questions from chapter 1 number systems of CBSE class 9. Let's take a look at the first question, which says to simplify the given number. So let's start by writing down the number given to us. I can write this 4 as 2 square. So I'm going to write as 2 square whole power minus 3 by 2. So this 2 and this 2 get cancelled, and I'm left with 2 power minus 3. So this 2 power minus 3 is nothing but 1 by 2 power 3. I can write this because a power minus m equals to 1 by a power m, right? So this becomes 256 power minus 1 by 8, because 2 cube is 8. Again, given that a power minus m equal to 1 by a power m, I'm going to write this as 1 by 256 power 1 by 8. Now I can write 256 as 2 power 8, right? So I'm going to write 2 power 8 whole power 1 by 8 in the denominator. 8 and 8 get cancelled. So the answer is 1 by 2. Let's take a look at the second question. It says 3 plus root 3 into 3 minus root 3. Straight away, it looks to me in the form of a plus b into a minus b, which can be written as a square minus b square. So I can write this as 3 square minus square root 3 whole square, which is nothing but 9 minus square and root gets cancelled. I'm left with 3. The answer is 6. The third question asks us to write this recurring decimal in p by q form. Let's follow a step-by-step process to do the same. So first, let's say let x equals to 18.48 bar. So this bar is both on 4 and 8. That means 4 and 8 are recurring. The next step is to multiply. Let's say this is equation 1. The next step is to multiply equation 1 with 10, 100 or so on, depending on the number of recurring decimals. Because there are 2 recurring decimals, I'm going to multiply equation 1 with 100. So multiply equation 1 with 100. So that will become 100x equals to 18.48 bar into 100. So after multiplying with 100, 2 numbers will come out of the decimal place, and this should become 1848.48 bar, which is equation 2. The third step is to subtract equation 1 from equation 2. Let's do that. So equation 2 is 1848.48 bar. Equation 1 is 18.48 bar. If I do subtraction, then I'll be left with 99x. And on this side, 48 bar are going to get cancelled. And I'm going to be left with 1830. I can write x as 1830 by 99. X is nothing but 18.48 bar. So I have written 18.48 bar in p by q form. In fourth question, they have given us 10 power 2y as 25, and they want us to find 10 power minus y. How to do that? Let's write down 10 power 2y equals to 25. Now I know that 25 is the square of 5. So 10 power 2y equals to 5 square. Now taking square root on both sides, will give me 10 power 2y whole power 1 by 2 equals to 5 square whole power 1 by 2. 2 and 2 gets cancelled, 2 and 2 gets cancelled. 10 power y becomes 5. Now I need 10 power minus y. We know that a power minus m equals to 1 by a power m. So 10 power minus y will be nothing but 1 by Fine. Fifth question asks us to simplify another expression. So let's start by simplifying what's within the brackets and then we can further simplify. So let's write 8 here as 2 cube whole power minus 4 by 3 divided by 2 power minus 2 cannot be simplified further, so I'm going to leave it. Now this 3 and 3 gets cancelled. This can be written as 2 power minus 4 divided by 2 power minus 2 whole power 1 by 2. So as we know, again a power minus m equals to a power m. So I can write this as 1 by 2 power 4 divided by 1 by 2 square, again whole to the power of 1 by 2. So I'm going to write this in this form. So right now it is in the form of a by b by c by d. So a by b divided by c by d. So I can write it as a into d by b into c, right? So I'm going to do this as 2 square by into 1 by 2 power 4 into 1 whole power 1 by 2. So this is going to become 1 by 2 square whole power 1 by 2. So this will become 1 power 1 by 2 by 2 power 1 by 2 whole square, which can be written as, so this gets cancelled. So this will become 1 by 2. Sixth question asks us to simplify this expression. Let's start with simplifying the individual elements first. Let's take 3 root 48. So I can write this as 3 root 16 into 3 is 48. I know that square root of 16 is 4. So I can bring this 4 outside, which will give me 12 root 3 because 3 into 4 is 12. Now the second term is 5 by 2 root 1 by 3. Now I know square root of 1 is 1 and 5 into 1 is 5 by 2 root 3. Whenever I see a square root in denominator, it's easy to simplify if we rationalize the denominator. So how do we rationalize the denominator? Multiply and divide by root 3, which gives me 5 root 3 by root 3 into root 3 is 3. So 2 into 3. So I can write this as 5 root 3 by 6. This cannot be further simplified, so I'm going to leave it like that. So this whole expression can now be written as 12 root 3 minus 5 root 3 by 6 plus 4 root 3. Now taking LCM, I'll get 6. 12 into 6, 72 root 3 minus 5 root 3 plus 6 fours, 24 root 3, which will give me 72 plus 24 is 96 root 3 minus 5 root 3 by 6. So 96 minus 5, 91 root 3 by 6. That's our answer. Now in 7th question, we are given an expression here and we are asked to prove that m minus n equals to 1. So let's try to simplify this expression and write in terms of the exponents m minus n. So let's start with 9, which can be written as 3 square. So whole power n into 3 square can be 3 square into 3 power minus n by 2 whole power minus 2. 2 and 2 gets cancelled, minus into minus plus. So I'm going to be left with 3 power n minus 3 cube. I can write 27 as 3 cube. So I'm going to write it as 3 cube whole power n divided by 3 power 3m into 2 cube. Now I can write this 27 as 3 cube. So I'm going to write it as 1 by 3 cube. Now this numerator here, we can see that all the bases are same, 3, 3 and 3. So I can add the exponents. So I'm going to write it as 3 power 2n plus 2 plus n minus, this is 3 power 3n and this is 3 power 3m into 2 cube equals to 1 by 3 cube. Now I can multiply this numerator by 3 cube and send this to this side. So 3 cube into 3 power 3n plus 2 minus 3 power 3n. This will go to the other side, which is 3 power 3m into 2 cube. Now I can see that this has 3 power 3n and this also has 3 power 3n. So I'm going to take that out as common and I'll be left with 3 square minus 1, which is equal to 3 power 3m into 2 cube is 8. So again, bases are same, so I can add the exponents. I'm going to write as 3 power 3n plus 3 into 8 equals to 3 power 3m into 8. 8 and 8 get cancelled and my bases are same now, so I can equate the exponents and I can write this as 3n plus 3 equals to 3m. Now I can take 3 as common, n plus 1 equals to m into 3. So 3 and 3 gets cancelled, n plus 1 equals to m. If I take n to the other side, I can write 1 equals to m minus n. So that's what we were asked to prove. Eighth question asks us to rationalize the denominator given here. We can see that there are 3 terms in the denominator. Let's take a look at how this kind of an expression can be rationalized. Now starting with 4 by, try to separate this into 2 terms. So 2 plus root 3 plus root 7. I can write it like this. Now in order to rationalize the denominator, I have to multiply with a opposite sign to what I have here. So 2 plus root 3 minus root 7 by 2 plus root 3 minus root 7. So the numerator becomes 4 into 2 plus root 3. So I have to multiply 4 with this and 4 with root 7 as well. So minus 4 root 7. Denominator is in the form of a plus b into a minus b. So we know a plus b into a minus b equals to a square minus b square. So this will become 2 plus root 3 whole square minus root 7 whole square. Let's start expanding the numerator. 4 into 2 is 8 plus 4 into root 3 is 4 root 3 minus 4 root 7. That's the numerator. Now the denominator. 2 plus root 3 whole square is in the form of a plus b whole square. So I can write as 2 square plus root 3 whole square plus 2ab, that is 2 into 2 into root 3 minus root 7 whole square becomes 7. Now this numerator, there is nothing further to simplify, so I'm going to write like this. Denominator 2 square is 4, root 3 whole square is 3, plus 2 into 2 is 4 root 3 minus 7. So this can be written as 8 plus 4 root 3 minus 4 root 7 by 4 plus 3 is 7, 7 minus 7, here the 7 and minus 7 gets cancelled. I am left with 4 root 3. So we can see that the denominator has not yet been rationalized and we still have a square root in the denominator. So the next step is to multiply this expression and divide it by root 3. So let's do 8 plus 4 root 3 minus 4 root 7 into root 3 by 4 root 3 into root 3. Now this becomes, so I have to multiply root 3 with each of these terms. 8 root 3 minus 4 root 3 into root 3 minus 4 root 7 into root 3 divided by 4 root 3 into root 3 becomes 4 into 3 because root 3 into root 3 becomes 3. So let me expand further. 8 root 3 minus 4 root 3 into root 3 is 4 into 3, which is 12. minus root 7 into root 3 becomes root 21 and 4 into 3 becomes 12. If you want to further simplify this, we can see that 4 is common in numerator and denominator. So if I take 4 as common, I can write it as 4 into 2 root 3 minus 3 minus root 21 by 3. 4 into 3. So 4 gets cancelled and I am left with 2 root 3 minus root 21 by 3. Ninth question asks us to prove that this expression is equal to 1. We have to expand the expression and see what happens. So this particular expression is in the form of a by b whole power m. So this whole thing has the power of a plus b, similarly b plus c and c plus a. So we know that when a division has an exponent like this, both the numerator and the denominator will get the exponent. So let's start by expanding it that way. X power a into a plus b by x power b into a plus b into x power b into b plus c by x power c into b plus c into x power c into c plus a by x power a into c plus a. So that can be expanded like this. Now let me start writing x power a square plus ab by x power b square plus ab into x power b square plus bc by x power bc plus c square, x power c square plus ca by x power ac plus a square. Now the bases are common in the numerator and the denominator. That means I can add the exponents. So let's expand by adding the exponents. This becomes x power a square plus ab plus b square plus bc plus c square plus ca. Now the denominator becomes x power b square plus ab plus bc plus c square plus ac plus a square. Here we can observe that a square plus b square plus c square plus ab plus bc plus ca, all of them are the same. The exponent of the numerator and denominator is the same. So both gets cancelled and I'm left with 1. That's how we have proved it. The last question asks us to simplify this given expression. Let's start by writing in terms of squares and cubes wherever applicable. The trick is always to see the exponent given to us and whatever is there in the denominator. Like we have 4 here and 3 here. So I'll try to write these numbers in terms of powers to the 4 and these numbers in terms of powers to the 3 so that they can be easily cancelable. Let's start. So root 25 is 5 and cube root of 64 is nothing but cube root of 4 cube plus 256. So 4 power 4 is 256. So I can write 4 power 4 power 1 by 4, 625. 5 power 4 is 625. So I can write it like this, by 1 by 4 cube is 64. So I'm going to write it like this. This 125 can be written as 5 cube. So I can write it like this. Now on further simplification, cube and cube root gets cancelled. I'll be left with 5 by 4. Here 4 and 4 will get cancelled. 4 and 4 will get cancelled. So I'll be left with 4 by 5 plus 1 by cube and 3. 5 cube and 3. So 4 square by 5 square. I can write this as 5 by 4 plus 4 by 5 plus this 5 square goes to the top. So it becomes 25 by 16. Now I have to take LCM of 4, 5 and 16. How to do that? So write 4, 5 and 16. 4, 4 4s are 16, and then 5, and then 4. So 4 into 5, 20, 24 is 80. So 80 is my LCM. And 20, so here it's 4, so I'll multiply with 20. 20 into 5 plus 16 into 4 plus 16 into 5. So 5 into 25. This becomes 100 plus 16 4s are 64. 25 into 5 is 125 by 80. So adding 125 and 164 will give me 289. So 289 by 80. That's the answer.